take that hypothesis and test it, and if it doesn't work, they invent something to make it work. And if that doesn't work quite right, they invent something to help the first invention make it work. Well, you may think I'm being funny on this, but read Einstein himself, and he tells you exactly that same thing in different words. As he said, it has to be pure invention. But that's the difference between induction and invention. In the one case, it's hypothesis, test, discard. Hypothesis, test, discard, until we finally don't have to discard. In the other case, it's hypothesis, test, invent. Test, invent, until we get something we don't have to invent anymore. When it was first discovered that atoms disintegrate under certain appropriate conditions and emit particles in so doing, it was a very natural hypothesis that the atoms are constructed of such particles. But now that we have found out that those particles do not have the properties that are necessary in order to be constituents of atoms, we have a totally different situation. We no longer have any justification for inventing something that we can find no trace of. But the general opinion still stands that these atoms must be constructed of particles. And present-day theories are obsessed with the idea that they have to keep on dividing and subdividing until they get to something that they can call an elementary particle. In fact, the whole situation with the physical particles is beginning to resemble that status of the fleas in that popular little verse that maybe most of you remember. It goes something like this: big fleas have little fleas upon their backs to bite them. The little fleas still smaller fleas, and so on ad infinitum. The impetus for this frantic search for an elementary particle of matter comes from the present-day concept of the nature of the universe, which sees it as one in which the basic entities are elementary particles of matter existing in a framework provided by space and time. But the modern discovery that matter can be converted into non-matter and vice versa has completely destroyed that concept. It's now obvious that matter cannot be the basic constituent, that there must be some common denominator underlying both matter and non-matter. And since that is the situation, there must be some level below which matter does not exist, and that which exists is this common denominator, whatever it is. For the moment, let's call it X. Well, this again is nothing particularly heretical. Some of our foremost scientists have emphasized it quite strongly. Heisenberg, for instance, is very clear on the subject. He's tried to figure out what this entity X could be. He suggests energy, but he has no idea, he admits, or did admit, how energy could fit the bill. So I'll return to this question of the identity of X a little bit later. In the meantime, let's consider further this question of inventive versus inductive theories and how they stand now. At the beginning of this century, when the modern inventive theory took over from Newtonian inductive science, the necessary information for constructing an inductive theory that would account for the new discoveries that had been made around that time was entirely inadequate. The information that could be collected was not enough to extend the existing inductive theories into what we may call the far-out regions, the regions of the very fast, the very small, and the very large. Now, there were a few of the essential building blocks already in place. The discrete nature of the units of energy had already been established. Radioactivity had been discovered, and the status of electric current as a movement of electrons had been determined. But there was still an immense amount of information that had to be collected before an inductive theory that was capable of being extended into these far-out regions could be constructed. That information has now been accumulated. And the final inductive step that was necessary in order to construct a theory that would extend into all these regions has been taken by the development that's the subject of discussion at this conference. That development, like a great many other results of scientific research, was a totally unexpected result of a project aimed at an entirely different objective. The original objective was to construct a theory or some means whereby physical properties could be calculated from the chemical composition. In some respects, that's not a very good subject for examination because it's been very thoroughly combed over by previous investigators. But on the other hand, it's also something that has a definite answer, because obviously those chemical properties or those physical properties are determined by the chemical composition. I want to say at this point that while I may be regarded as a heretic, that's not by inclination. I started from a purely conventional base. And my first work was directed entirely along conventional lines. The base from which I started was the idea that's embodied in the periodic table. The idea that the principal properties of the chemical elements are determined by two variables represented horizontally and vertically in the tables. The first really important advance that I made, at least it's important in view of what turned up later on, was the finding that one of these variables takes both positive and negative values, whereas the other one takes positive values only. Then, after a good deal of additional trial and error, I found that there were actually 3 variables rather than 2. Now, while all these efforts to determine the form of the mathematical relations were going on, I was also struggling to determine the meaning of the terms in those relations. That's the other essential for an inductive theory, one that will be conceptually valid. Here again, I didn't stray off the reservation for quite a while. I started from the purely conventional idea that the atom was made up of a group of particles, and that the properties, the differences in properties between the elements, are due to differences in the number and arrangement of those particles. But after some years of work, I got nowhere, exactly nowhere. So I had to try some different approach, or quit the job. I tried a number of things and discarded them. The old trial and error process that we learn in college. Finally, I got the idea that perhaps some of the differences in the properties might be due to differences in motions of the particles, rather than in differences in the actual number and arrangement of the particles themselves. So I tried that. Well, that didn't work either. But in the process, there were some indications that I might be on the right track. So I just didn't throw that away immediately. I worked some more on it. And as I worked on it, it became evident that the more emphasis I put on the motions and the less emphasis I put on the number of particles, the more these indications were that I was getting somewhere. So finally, I simply discarded this idea that the motions might account for some of the differences in the properties, and I substituted the idea that the motions account for all of the differences in the properties. Now, that was the first really radical conceptual jump that I had made in the whole project. And it led to some important consequences. Since I had determined that there are only 3 main variables, then if we attribute them to motions, it follows that they must be motions of the atom rather than motions of a large number of constituents, because it's rather difficult to parcel 3 over a large number. But then when you come to the conclusion that they're motions of the atom, then motions of an object such as that kind must almost certainly be rotations. And the number 3 then suggested that these were rotations around 3 perpendicular axes. And in that event, the differences in the magnitudes of the properties can be very easily explained as differences in the speeds of rotation. So I had come then to the point of an atom constructed entirely of motions, with 3 rotational motions around the 3 perpendicular axes, and different speeds in the different dimensions. So I had identified this quantity x. The quantity x is motion. When we subdivide matter, we subdivide down to a certain point, which we find is the atom. We subdivide further, we have motion, not matter.